talk about similar polygons. Last unit, we talked about congruence. And in a congruent figure, they had the same shape and the same size. If they wanted to be congruent, that must be true. Today, though, when we start talking about similarity, we're still going to have the same shape. We ain't trying to compare a square to a circle or a triangle to a dodecahedron. It is. We are trying to make sure that we've got the same shape, but now we're going to have different sizes. So our side lengths will be different. So last unit, polygons were congruent if and only if they had 3 corresponding angles that were congruent and 3 corresponding sides that were congruent. Today, though, for similarity, our angle relationship remains. We've still got 3 pairs of congruent angles. But instead of 3 pairs of congruent sides, now we've got 3 pairs of proportional sides. So if you're wondering, why on earth did we do all those proportions yesterday? Well, it's so we can get used to being able to find missing side lengths. The ratio of our corresponding sides is called the scale factor. Where have we heard that term before this year? Where did we hear scale factor? It was in Unit 1.
Was it like the size of, like, would it feel like comparing 2 units?
Kind of. So in Unit 1, we had transformations. So we had a translation, which just slid our figure, but kept the rigid transformation. We had a reflection, which flipped our figure. We had a rotation, which turned our figure. And then what was our 4th transformation? A dilation, which did what? Or smaller, based on the scale factor. And we multiplied our scale factor into this, to our values. The same thing is happening. We're going to have 2 different figures, and the ratio of their sides are our scale factor. Another thing that'll come up, if the polygons are similar, then their perimeters are also proportional. So let's work on finding our scale factor first. What is the scale factor for triangle ABC to triangle DEF? Now, the cool thing about this is it doesn't matter which sides we choose. We just have to make sure we choose the same corresponding relationship. So when we look at ABC to DEF in our 2 triangles, can somebody give me a pair of corresponding sides? What? AB corresponds to DE. So she's right. So we got a single hoop going to a double, single going to a double. Those angles are kind of like our navigation beacons. They can help get us in the direction we want to go. So AB is corresponding to DE. And even if we go to our statement, look at that. AB corresponds to DE. That rule still exists. I'm sorry, I didn't go up high enough. That rule still exists. So we're going to set up now our ratio. So AB over DE. And the important thing here is we remember that order matters. So AB is proportional to DE. What's the value that they give us for AB? 8. What's the value they give us for DE? 12. And when we reduce that, we get a scale factor of 2/3. So that is from the smaller triangle to the bigger triangle. In our second box, we're going to go from bigger triangle to smaller triangle. let's pick a different pair of corresponding sides. Which ones y'all got? Who's got something? Boom, boom, boom.
12, 16. Oh, how about 15 to 10?
So BC and EF are corresponding, right? There's our navigational beacons. Double, double, goes to triple, goes to triple. Tells us which way we're turning. It's just like that daggone GPS on our cellular devices. They tell us which direction we need to get out yonder. So this time, the DEF triangle is going to go on top. So we got side EF to side BC. And if we've done it correctly, we should see a scale factor similar to the one above, but just the reciprocal of it. It should just flip. Flip, flip, Philadelphia. So what's the side length they give us for EF? 15. BC is 10. 15 over 10 reduces to 3 over 2. Yay. So I guess I could highlight that in green so we kind of know what's going on. And then I can highlight that in yellow.
Can they
Okay.
hear us?
Sir?
Can they hear us?
Yeah.
Oh.
All right. What about the ratio for the perimeter? So in the statement above, what did it tell us about our perimeter? If they are similar, then our perimeters will also be proportional. So depending on which perimeter we go, which direction, we'll either get 2/3 or 3/2. It says go from DEF to ABC. So which scale factor do you guys think we're going to find? 3 over 2. Let's find out. So what is perimeter? The distance around a figure, right? So 12 plus 15 plus 21. That's our DEF triangle. And then we've got 8 plus 10 plus 14. It's our ABC triangle. 12 plus 15 plus 21. 31, is it what? 48. Over 8 plus 10 plus 24. 32. Math frac that sucker. And what's it give us? 3 over 2. So our scale factor is the same. Doesn't change. No. So what is a similarity statement? Well, a valid similarity statement must match corresponding angles and sides, just like a valid congruency statement. Matched up corresponding angles and sides. The symbol for similar is just the mustache. The equal sign's gone. So for similar, we're just going to put the mustache. So for the two above, we would say triangle ABC is similar to triangle DEF. Triangle ABC is similar to DEF. All right, so let's go ahead and see if we can't master this whole matching up congruent angles and corresponding sides. Let's see what happens. Let's see if it's different than the way we learned it way back in the olden days. Maybe if I hit the correct button, instead of having everybody ride a roller coaster of emotions, we'll be in good shape. So our statement, JKL is similar to PMN. So what are our congruent angles? Angle J is congruent to who? Angle P. Well, that's not different than what we've done. Angle K is congruent to angle M. And then angle L is congruent to angle N. That's the exact same thing we've done. Nothing is different there, guys. Pretty sweet stuff, if you ask me. Sides is a little different. So we're going to set up the proportion that relates the corresponding sides. So do you guys remember how we identified congruent sides in the last unit? We just looked at the statement and we said, hey, the first one is JK, so the first one on the other one had to be what? So JK corresponds to PM. And that's the same ratio as KL to MN, which is the same ratio as JL to PN. So instead of just saying those guys are congruent, we know that they create the same ratio. So the ratio created by JK is equal to the ratio created by KL and MN, which is equal to the ratio created by JL and PN. And of course, if we wanted to, we could flip it. Any questions before we push on?
So that means that those triangles are, that means that the angles are typically all proportional. All the angles are proportional.
They are proportional because they are congruent.
Okay.
The angles are still congruent. It's the side relationship that changed a little bit.
So that means that all the angles are the same as in the other one?
Correct.
So
K, if K was 30, then P or M would have to be 30.
yes.
Our angles are still congruent.
Okay.
Does that help?
Yes. I just thought when you put all of them equal to each other, those are just
Those are the ratios of our sides.
the scale factor.
Correct. So they all would have the same scale factor, which means they're all equal to each other. So it's merely about identifying which sides are congruent. Or which sides are similar. I'm sorry, not congruent. Number 2, this is what trips you guys up. When they start putting triangles inside of triangles, for some reason, our brains go into like factory default broke mode. So we've got 2 figures here. We've got this triangle inside the other. Maybe if I write in a smaller highlighter. So I've got this triangle that's located inside the other. And then we have our triangle that's the bigger one that's outside. So our corresponding sides, even though one is inside the other, our corresponding relationships will still exist. They're still going to have a same ratio as long as they are similar. So when we look at our angles, what are our angle relationships? Angle X is congruent to angle R. Y is congruent to Y. Why? Why are those 2 congruent?
Because they're Y.
Yeah, they're both Y, but why? They're both the same, but for different triangles. What do we call that? What did we, it's a shared what? It's a shared angle instead of a shared side. Last unit, we saw a whole bunch of shared sides. This unit, we're going to see a whole bunch of shared angles. Let's go. Tote, lit, bam. All right, and then lastly, angle Z is congruent to angle S. And then now our sides. I can look at the figure or I can just go to my similarity statement. XY is corresponding to whom? RY, great answer. YZ corresponds to YS. And lastly, XZ corresponds to RS. Yes, ma'am. Well, that's all fine and dandy for a daggone triangle. But what happens when they hit us with one of these quadrilaterals? That's got to change the rules, right? It doesn't. Our rules are going to stay the same. We're going to look at our similarity statement. It's going to tell us which angles are congruent. We're going to look at our similarity statement. It's going to show us which sides are proportional. So J is congruent to Q. K is congruent to R. L is congruent to S. My pen's running out of ink or something. And M is congruent to Q. So again, we can just look at our similarity statement. So JK corresponds to QR. KL corresponds to RS. LM corresponds to SP. And finally, JM corresponds to QP. So somebody last class said, hey, what about KM? Well, can KM be a side? No. So it doesn't have the same proportion. Y'all ready to throw some algebra in this geometry? Everybody's favorite
No.
thing? Wow.
No.
Well, tough. Because we're doing it. It is. I don't know. I want to. For the scale factors are similar with a scale factor of 6 to 5. Find the value of X. First off, let's identify which sides are corresponding. Who corresponds to whom? X goes with 28. So we need to set up our proportion to help us solve for X. So they told me a scale factor of 6 to 5. So I'm going to go bigger triangle on top, smaller triangle on the bottom. Why do y'all think I'm doing that? Why do you think I want to go big triangle on top, small triangle on bottom?
It's easy.
No. And our scale factor is the bigger number on top or bottom? On top. So the bigger triangle is naturally going to go on top. If you look to the one to the left, the bigger number was on the top or bottom? Bottom. So where did our bigger triangle, our bigger rectangle go? Probably parallelogram, not a rectangle. My apologies. All right, so we're going bigger triangle. Is that the one with X or the one with 28? X. Don't let it fool you. And it is equal to a scale factor of what? 6/5. What's that? And now we do the math. Now that we've got our proportion set up, we just do the cross product property. 5x equals 28 times 6. Will you ever have to use one more time? I'm sorry. Not yet, but it might be. When we get to circles, guys, we're gonna have to factor again. I promise. Oh.
I thought we were done with factoring.
No, we're not done with factoring.
Oh, no.
Divide both sides by, is it 5? Did we get a decimal? Them sneaky rascals. They know how much I hate decimals, and they brought one in there anyways.
You don't like this?
No, I don't like decimals. I like everything clean and neat. Decimals are messy. And it's all like, you got to round, and that's just too much. So x equals what? 33.6. I like it when it's just wrap it up in a bow, throw it on the shelf, we outie. Yeah,
That's what
I know. That's why I don't like decimals.
So does that mean if we get a decimal on your test or quiz, you only got?
I will tell you if there could be decimals or not. Like most of the time on the quiz, I tell you, probably shouldn't get a decimal right there, folks. You did something wrong. If ABC is similar to DEF, find the value of X. What do we got? AB corresponds to who in the other triangle? DE. They tried to mess with y'all, didn't they? They said, I bet you if we lay this triangle on its side, they'll think X goes with 20. And then BC corresponds to EF. So we're going to put yellow on top of yellow and green on top of green. And then I'm going to show you a little secret at the end there that doesn't really matter. So X over 25. Oh, cannot write in highlighter, dummy. Because the X is on the left, and that's the way I feel like doing it.
Okay. So
It does not. Unless they give you a scale factor, then it matters.
okay. And now you have to put the.
So if we put the X on the top, on the left, who needs to go on top on the right? 28 from the same figure. We need to put the same figure. 28 over 20. Time for some big numbers up in here. Cross product property. 20x equals 28 times 25. I'm going to guess that's about 700.
That's exactly.
500 or 700? It looks like it's about $7. Oh, I'm sorry. So we got 20x equals 700. Divide both sides by 20. Now, man had a, and then as long as my yellows and my green still line up, so what I mean by that is 28 was green, 20 was green, X was yellow, 25 was yellow. As long as those pieces are still kind of lined up, I can have the wrong setup, but it'll still get me to the right answer. Look, 20x equals 28 times 25. That's the same thing we got when we put them the right way. That's the beauty of proportions. even if I get a little squirrely and get a little sideways, I can still come along the right answer.
As
You
long
made
as
it?
you don't mess it up too much.
As long as we don't cross triangles. Now, if I would have put X on the top on the left and 25 on the bottom on the right, now I'm no longer matching corresponding parts correctly. Now I'm jacking it up. That will mess you up quicker. Than a rabbit in the middle of a wolf pack. All right, let's look at number 10. Uh-oh. You think they're going to make us factor? Could they make us factor?
No, please, no.
Wow, son. Let's find out. So what corresponds? GM goes with who? XE? XD?
D.
And then GA goes with XK. I think we might be safe. So we've got, just because I like to go left to right, we're going 36 over. So if I went yellow on the left, I'm going to go X plus 6. Oh, come on. Factor for me one time. 32 over X plus 3. Darn.
Why can't we just swap
We can foil next problem, don't worry.
both X's on the same side?
Can you put, you could have, yeah, just like we did on the last one.
Can we do that instead and skip factor?
There is no factoring. If you messed it up, you would end up having to factor though. Don't mess it up. Don't rock the boat, baby. Rock the boat, don't tip the boat over. So we got 36 times X plus 3 equals 32 times X plus 6. Cross product property, write it out so I don't jack it up, homie. Distribute into both terms of our binomial. 36x plus 108 equals 32x plus like 172 or something. It's promising. I like 192. Appreciate it. It's almost the same thing, but it's not. So we're going to subtract 32x from both sides because our goal now is just to isolate that variable. And because we're geniuses, we're also going to subtract 108 at the same time because y'all are smarty pants. That's a big old fat line. So we get 4x equals. Yes, 4x equals 84. No decimal? That's good. I don't like decimals either. Fractions, though. Fractions are our friend. X equals 21. All right. Your homework